Hi friends, this is Arun. In this video, we'll have a look at bitwise operator. It is very simple, which we have studied in the school. I'm just going to rush through the stuff, but it is very important to, and you can solve a lot of elegant solutions using these operators. And more importantly, if you are sitting for an interview or a um, written exams, mostly they'll ask some one or another question from this. Okay, so first let's start with the relevance. Okay, the C or Python. Python is a new language, but when C was originally developed, it was more towards writing for assemblers, kernels, device drivers, interpreters, those kind of things. So in that, every manipulating or using every bit is a key thing. Okay, that's the reason why C has a very strong hold in bitwise operator. If you go to Java, you will not have that. It will be there, but it's not a big deal in that because Java has other things to play with. Okay, whereas in the same case with Python and C are same. Both the guys interact much with the hardware. Even in Python, you have Arduino or Raspberry Pi, which you will interact directly with the hardware. In that, you will set the ports like I/O ports, all those stuff. Okay, so that is the reason why we need to study at least bitwise operator apart from the interview perspective. Okay, so these are some of the six suite bitwise operator: and, or, XOR, complement, right shift, and left shift. Okay, so all are straightforward. Like, let's go for the truth table. So when you look at the and operator, it's simple. If both the guys are 1, you will get 1. So let's start with this thing. So if both are 0 or 1 is 0, you will get 0. If both are 1, you will get 1. Or is either or case. Okay, if one guy is 1, it's good enough for him to become a 1. Okay, good enough become a true. Whereas XR, it is little tricky. If both the guys are same, you'll get a 0. Okay, so if both the guys are same, here also it's 0. If they are different, you'll get a positive thing. Okay, it's like you imagine a couple. If in a couple, like if both are having the same characters, you will always have a fight. So it should be a complementary character. Okay, and last but not least, the ones complement. Okay, all it does is like inverse that guy to another one. For example, if it is 0, it becomes 1. Again, 0 1. If it is 1, it becomes 0. Actually, you don't need 4 options for this because one's complement always plays with a single value. Okay, it's not a binary thing. So this is a simple example for it. For example, here it is and, so both are different, it becomes 0. Where it, except this guy, the rest of the all are like 1 or 1 or 0. So every guy becomes 0 and only this guy becomes 1. Whereas in R, it's not like that. These two guys, this guy, and here it's both are 0, so they can't do much. So except this guy, everybody has become a 1. Whereas XR, it's slightly different. Like, both has to be alike. Sorry, different. So this guy is different, this guy is different, this guy is different, this guy is different. Here they are same, so it becomes 0. And here they are same, it becomes 0. Okay, that's all. So that's the thing. Whereas one's complement, as I said, it is a single unary thing. So it just transposes the zeros to 1 and ones to 0. That's it. It's called one's complement. Okay. So left shift of 3 means it'll shift push 3 things away. So these 3 guys will go off, like 1 and 2 and 3. These 3 will go off, and zeros would be appended from the left hand side. Okay, if it is right shift, these first three guys will go off, and 0 would be appended from this end. I mean, it's directly symbolic. Okay, you can understand from that. So that's all. Here it is. Let's go to the code and have a look at the code. Okay, I have a code. Let's so what I'm doing is I am using unsigned int, not a signed int. Unsigned int means like a typically in C, the last bit is for the signed bit. If it is 1, it is positive. If it is 0, it is negative. Somewhere it is. Okay, so don't worry about it. That's last bit is signed bit out of 8 bytes, 8 bits. Okay, so let me pick some value. I think this is not needed, so I'll set it as 0. So whatever value I give it, first I print their binary value and then start doing the other stuff. Let's give some number. So 4 and then 7. So 4's binary value is like 0 1 0 0 0 1 here it comes, because 2 power 0, 2 power 1, 2 power 2. Okay. And whereas 7, it is you have to set all the bits. So in and what happens is only these two guys are different. Sorry, these guys are different, so it goes off. Whereas in R, like all these three will become one, rest of the things are zero, so it's completely ignored. Let's go to the XR. XR is like only if you are different you will get the value. So these two guys are different, these two guys are different, these two guys are same. Okay, so it becomes zero. So except these two, all are zeros. And then one's complement is similar, like it's a negation of it. So here first two are zero, here it became one, and last four are zeros, and last became one. And then right shift, let's sorry left shift and right shift. Okay, so here towards this side, so what who will go off, like these three will go off. Where it is, b b b b, here it is. Okay, these three will go off. Okay, all are zero, so there is no matter, so all new two will come at here. So for two shift, it's two is gone. And if it is left side, so these two ones will gone, is gone, see here. Okay friends, that's all. Thank you, bye bye.